What if the true cause behind the universe's expansion isn't dark energy? What if it all starts with something as simple and beautiful as ice? Morgan Shatee Byers presents the Ice Nucleation Universe Hypothesis. My name is Morgan Shatee Byers, and I believe we need a new way to understand how our universe is growing. Current theories say it's dark energy, an invisible force we don't understand. But I believe something else is at work. Imagine this. Two magnetic fields collapse into each other in the vast emptiness of space. This sudden collapse causes ice nucleation, a process where water molecules form into crystals, usually at cold temperatures. This crystal formation, I propose, is what initiates emptiness, creating the cold, expanding void we call space. But the story doesn't stop there. As the nucleation spreads, it pulls in metals from the surrounding space. These metals collide, creating sparks of friction, and from these sparks, stars are born. Planets made of copper, a metal known for its electrical conductivity, begin to generate electricity through magnetic induction. This electricity gives rise to magnetic fields, which help align the orbits of planets and shape solar systems. The cold vacuum left behind by nucleation becomes the canvas of space, a vast cold void where celestial bodies form and grow. Now let's pause and ask, what's missing from this picture? What do we need to make this theory scientifically sound? I'm not saying mainstream science is wrong, I'm saying, what if there's more? What if ice nucleation and magnetism play a hidden role in the dance of galaxies? To evolve this theory, we'd need collaboration with physicists and cosmologists, models that show how magnetism and ice can shape space-time, and observations from deep space telescopes looking for cold zones or metal alignments. Every great theory starts with a question. Newton asked why apples fall. Einstein asked how time and space bend. I ask, could the cold stillness of ice be the spark that builds the cosmos? Subscribe for more hypothetical cosmology. To evolve your idea into a viable cosmological theory, consider bridging scale. Ice nucleation works at small scales, so how could its principles apply to the structure or fabric of space itself? Energy source. Expansion requires energy, so how does your mechanism produce or explain this energy? Testability. What would we observe in deep space, like patterns in voids, magnetic alignments, or unusual ice distributions, if your hypothesis were true? You might draw inspiration from quantum vacuum theories, entropic gravity, or magnetohydrodynamics, all areas exploring subtle forces at cosmic scales.